Solving vector word problems can be really difficult. So I wrote out some steps that a lot of the navigation word problems will follow. And hopefully if you kind of can keep these steps in mind, it'll make the process a little bit easier. Usually you want to start by coming up with two vectors using this formula. And then you want to try to add the two vectors together. And then depending on what the question's asking, oftentimes it's asking for the magnitude or direction. Looking at this example, an airplane is flying at a speed of 500 miles per hour due east. As you're drawing these out, I would draw little compasses before each vector. So if it's going east, it's going to the right. It encounters a wind of 70 miles per hour, so another little compass, 70 miles per hour at an angle 60 degrees south of east. If this is east, it's going 60 degrees south of it. So this angle is 60 degrees. It is going 70 miles per hour. What is the resultant speed and direction of the plane? So the resultant vector is going to be connecting the beginning to the end. So we want to find this first vector, then find this second vector, then add the two vectors together to come up with this vector, and then find the speed or the magnitude and the direction. Using the formula magnitude cosine, magnitude sine, the magnitude of the first vector is 500, and the direction angle, it's just pointing to the right. It's 0 degrees or 360 degrees. Still that same vector, the magnitude is 500, and now we do the sine of 0. The second vector, the magnitude is 70, and the direction angle isn't 60 degrees. Remember, direction angle is positive x-axis in the positive direction of the vector. So that's gonna be 360 minus 60. Now we can add those two vectors together. So in your calculator, when you add the x's, you'll get 535. And then you add the y's, negative 60.62. So this is your resultant vector. Now we need to find the speed or the magnitude and the direction. So the magnitude is square root of a squared plus b squared, and we get 538.42 miles per hour. To find the direction angle, I'm just gonna redraw the vector that we care about right now, that resultant vector, this one. So it's in the fourth quadrant. It's going right and down. Remember, to find direction angle, we can make it into a right triangle, and then we can do inverse tangent of y over x. But remember, that tells us the angle in the triangle. We need to find the direction angle, which is positive x-axis to the vector in the positive direction, and that gives us 353.54 degrees. I know that was a lot, but like I said before, if you can keep those steps in mind of coming up with the two vectors, adding them together, and then using that to find your magnitude or direction, a lot of the word problems go through that similar format, and that'll hopefully get you through most of them.